This is a Leaving Cert higher level question involving solving the intersection of three planes. So we have three equations and three variables we want to solve. Well, if we add a and b, we will see that the z's will cancel out. So we'll try to form two new equations without z's. So we'll write down what a is, and we're going to write down what b is underneath it. We'll see that we have a plus z and a minus z. So these will cancel out or add up to 0. So when we add this up, we get 3x plus 2y, and that equals 7. So this is the first new equation we have. Now let's also use c and 2 times b. If we add these together, we'll also get an equation without z. So we have 4x minus 3y plus 2z equals 4. And we have another equation. If we double equation b, we get 4x plus 2y minus 2z equals 2. So when we add these, again we see that the z's are adding up to 0. So we get 8x minus y is equal to 6. We'll call this equation E. So now we have two equations, but they're only in x and y. So this is like a junior cycle question. So if we add 2 times e to d, we'll see that the y's will add up to 0. So we'll do this. So we're doubling equation e. We get 16x minus 2y is equal to 12. When we add this, we see that the y's are cancelling out. They're adding up to 0. We get 19x equals 19. So it follows then that x must be 1. Now that we know the value of x, it's straightforward enough to find the value of y. So we might use equation E. So we have 8 times x, which is 8 times 1, minus y is equal to 6. And we see, well, if we take 2 from 8, we will get 6. It follows y is equal to 2. And now that we know what x and y is, we could sub these two values into one of the original equations. Maybe a looks simpler. So we have x, which is 1, plus y, which is 2, plus z is equal to 6. Well, 1 and 2 is 3, and 3 plus 3 is 6, so z must be 3. So the intersection point of the plane is point 1, 2, 3.